That's what it looked like because I didn't see like a link.
No, it's in the
old one.
Yeah, the new one. I didn't put the one up there for last class. I thought I did.
Yeah, you did.
Okay, I'm like, yeah, the one from last class is up there.
Yeah, I went back into it.
Yeah,
Like
so
that's the stuff I missed.
Yeah, so they'll always be there for you. That's why I like that site, because they're always going to be there. So they're never going to go away. And you actually, if you want, you can go back to some of the older classes, like, because I list the topics that I cover above the video. So you can go look and say, okay, I need this topic. Let me go in the video to find that topic. And that's one of the ones I cover. So I might have said something differently in that class, or a student might have asked a question in that class that triggered something for you. So it's like, they're always there. That's kind of why I like that option for people. All right, so the first thing we're going to look at is some parabolas, looking at finding some information from parabolas. I know a couple questions came up from a couple students over since Thursday about factoring and those type of things. So I want to go over that briefly first, but I'm going to go over looking at a parabola first, finding some major information from it, and then we'll look at the actual equation version of a parabola and find the same basic information. I'll show you how to do those things. So, what is the major parts of a parabola? What are some of the major information that we'd want to find? X and Y, not necessarily X and Y values, or specific. The intercepts, yes. We want to find the x-intercepts and y-intercepts. I heard vertex already. Yeah, if I can spell it correctly. There we go. What else? Yes. The axis of symmetry. And yeah, if we get some of this information, we should be able to make the equation from this information as well. So, but those are the four main pieces of information that you want to find from a parabola. So in this one, since this is a graph, it makes it a little bit easier because we can just look at it and find the information. What's the y-intercept? Yeah, y-intercept's right there. Is that 0, -3? What is my x-intercepts? Or how many x-intercepts do I have in this problem? I have 2. Do I always have to have 2? No. What other options can I have? I can have 1. Can I have 4 in a parabola? Not in a parabola. If I had 4 intercepts, what type of equation would it be? So the intercepts go with the degree. So if I have 4 intercepts, I'd have to have a fourth degree equation. So a parabola can have at most 2 intercepts because it's the degree of 2. So I can have at most 2. I can have 1. I also can have none. It doesn't have to cross the x-intercept. This one crosses it twice at -6, 0. And -2, 0. So those are my 2 x-intercepts. And I totally forgot to ask this because, like, as strange as it's, anybody colorblind? Good. Every so often I have somebody in my class that is. I have easy ways to fix it so you can see all the colors. So that's why I wanted to make sure I asked before I kept going with a variety of different colors on the board. And somebody goes, I can't see what you're writing. What was the other piece of information we need to find? What's the other major point that's on it? We have x-intercepts, y-intercepts. We got those. Then the vertex. Where's the vertex? Yes. This is on the top. That would be considered a what? A maximum. So I can have a maximum or a minimum depending on the direction the graph goes, right? So in this case, I have the maximum, and this one's at -4. -1. And then my axis of symmetry Goes right through my vertex. My axis of symmetry. Yes. Oh, you're right. It is positive one. Good catch. Okay. Everything else was negative, so I just kept with the negative train. All right. So those are the major pieces of information that you get from a parabola. This actually is one of the topics that's in chapter 2. So now that we have this information, can we make the equation from this? Okay. So how would I make my equation from this? So what are the different formats of a parabola that I can draw? Right. So so just like remember the a linear equation, we have slope-intercept form, we have point-slope form, and we have standard form, right? Are there different ways that we can write the parabola equation? Yeah. What are they? So we have 3, actually. We have intercept. So if x equals a, x minus, we'll do m and n. That's your intercept format. We have vertex. And then we have standard. This is the format you typically see. So just like we have for linears, we have 3 different methods for parabolas or quadratic equations as well. Depending on the information you have, depends on which one of those is going to be easiest to use. Okay. Every one of them, you need at least 2 points to do it. So in the intercept method, you need the 2 intercepts. If you have no intercepts, you're not going to be able to use the intercept method, obviously. But you're going to need 2. If you have 1, it's the same point twice. Then you also need another point to be able to find your A. Your vertex form, you need the vertex and another point to be able to find your A. Standard form, it's typically 3 points that you need to find it because you're looking for A, B, and C, so you would need 3 different points to be able to do your system of equations for that. So let's look at this one, and we'll actually come up with the equation for it. So since this one, I have my vertex, let's use the vertex form. If we have our vertex, that's the easiest one to use. So I know my H is -4, and my K is +1, not -1. So I can plug that information, and then I need a point because I have to be able to solve for A. So you can use any point you want for this. I would typically use one of the, you can use the y-intercept or the x-intercepts at this point because one of them is 0. So let's use the y-intercept. So I have x is 0 and y is -3. So we'll plug all that in to my vertex form. So -3 equals a 0 minus -4 squared plus 1. So I can subtract the 1 over, so I get -4 equals a times 16, because we have +4 squared, 16. So I get -1/4 is a. So this equation would be y equals -1/4 x plus 4 squared plus 1. And that would be the equation. Okay. So when you're looking at a parabola, if you have a graph, you can use that information to be able to find it. The intercept method would have been the same thing. I would have just used the 2 intercept points and one other point to be able to find A, but I would still gotten the exact same A. The A never actually changes. All right. Any questions on how to find information from a parabola? This, I'm hoping, should all be a review at some point. You should have seen this at some point in the past. Hopefully, this is more just a refresher. All right. The other thing that typically comes up is factoring. And this comes up in a lot of things. So we'll go over factoring real quick. Let's do. Let's not want to write pluses today. All right, so how do you factor this one? Anybody remember? Go ahead.
I think you split the equation to 2 parentheses, and one of them is gonna have, they're both gonna have x.
Okay. Yeah. Yeah, so we're looking for 2 numbers that multiply to 6 and add to 5.
X
Okay.
plus 2 and x plus 3.
Yeah, so in this case, it's 2 and 3. If you can't come up with it right off the bat, you start off with 1. So 1 and 6 adds to 7, doesn't work. Yes.
I actually emailed you
Yes.
about this type of thing because I found a different.
Oh, there's a few different ways to do this.
It's the same. What multiplies for that, but adds to that.
Yeah.
But it wasn't the right answer. It had a different one.
That's interesting.
Um.
On the one you sent me,
Yeah.
I can pull it up. All right, so let's do this one, and then I'll come up with that one.
'Cause I kept doing it. I'm like, what am I missing?
Let me look
And
at
then
the.
I asked about like the FOIL method.
Yeah, let me look at the problem you sent me. Because I know you clicked on the one that you sent. It's z squared plus 10x minus 24, right?
Yeah.
Okay, let's do that one real quick. X squared plus 10 and 24. Okay. So you got x squared plus 10x minus 24. All right, so we're looking for 2 numbers that multiply to negative 24 and add to 10. So if you start off, so my guess is it's a sign issue that you were having. When you're looking at them, always make sure to take the signs that's in front of them. So we're looking for 2 numbers that multiply to negative 24, not positive 24. Because if you did positive 24, you got 6 and 4.
Because I always make sure that the second number is
Yes.
the right.
Yeah, because if you did it, you would have gotten 6 and 4, which would have added to 10. But they don't subtract. In this case, we're looking for a negative. So in this case, yeah, the answer is going to be you have a negative 2 and positive 12, which will give you multiplied to negative 24, and then add to a positive 10. Yes.
X plus 12 and x minus 2.
Yes, that's the root starter.
Yeah, I did that in my head.
Yeah.
In fact, a lot of these things I did in my head.
Yeah, these ones you should be able to. These ones are pretty simple, straightforward. You should be able to do them in your head.
I'm assuming you know if you can see what I've been doing on Alex, but I completed some topics in less than a minute.
Yeah, it happens. The more
Those are
complicated
quick,
ones are like
easy tasks
this.
for me to do.
More complicated ones are like this. Come on, right? Nope. Two x squared plus 3x minus 2.
Oh, it's 3x, not 5x.
Yes, it's 3.
Looks like an incomplete 5.
Yeah, no, it was an incomplete 3. All right. When you're looking at a problem like this, there's a few different ways the teachers show you how to do this. All right. There is the guess and check method, which is kind of what we just did for the other factoring. That does work. I find it a little messy. We're going to kind of slightly do that, but I do it by what's called factoring by parts, because it does work for a lot more problems and it will always work for this problem. So what I do is I take the 2 and the -2, you multiply those two. So I'm looking for two numbers that multiply to -4. Yeah. Yeah. Multiply by -4 and add to 3. So give me two numbers that multiply to -4 and add to 3. -4 and +1, right? Oh, +4 and -1, the opposite way, yeah. So 4 and -1. Now, what I'm going to do is I'm going to split this middle one. And it doesn't matter the order you put them in. It'll still come out to be the same answer. So 2x plus 4, x minus, make this a little better. So I split the middle term. And now I'm going to factor out of both sides. So what can come out of this side is a 2 and x. And what's left is x plus 2. What can come out of this side? And you always take that sign. No matter what it is there, you always want to take that sign. So -1 comes out, and I'm again left with x plus 2. If you did it right, the parentheses should be the same. If you didn't, fix something. You either picked the wrong numbers or you factored incorrectly. So then my final answer is 2x minus 1, and then x plus 2. And that's it factored. That'll always work if you can factor it into rational terms. Okay. The method that always works no matter what you do is the quadratic formula. That one, no matter which problem you have, that'll always give you the right answers, even if they're complex. So, okay. All right, so factoring comes up a lot throughout the rest of pre-calculus and a ton through calculus. And I will tell you that's the number one thing the students screw up in calculus. It's so simple sometimes. It's like, those are the things like, oh, I understand this. And it's like, when you get to a problem that has, say, signs in it that you have to factor, it's like you totally forget all your rules of factoring, but it's the same rules. We're just going to replace sign with just an X, and then you do the problem and we replace it back. So it's like those things, once you get to the more complicated ones, it doesn't look like the simple factor you have, and you forget those simple rules that go back to this. So keep that in mind with your factoring. All right. Next problem. The next one is, symmetry. All right. The next thing we're going to start to look at is symmetry in even and odd functions. All right, first thing I'm going to actually do before we even actually do symmetry on these is let's look at, is it a function or not? Because that's always something nice to refresh people's memory on. Is the first one a function? Yes. Does it have an inverse? Is the inverse a function? No. You could tell, so here, functions are easy. That's the vertical line test, right? Straightforward and simple. Inverse is a horizontal line test. So if you take it, and if a horizontal line hits it any more than once, it does not have an inverse function. It might have an inverse, but it doesn't have an inverse function. So in this case, this would be like a sine function, or actually this one's like a cosine function. So you have arc cosine, which is an inverse, but that's not a function because multiple values will work for that one. So vertical test is function, horizontal test is the inverses. We will cover inverses a little bit too, so don't worry about that. All right, so the first one is a function. Is it symmetrical? Over which axis? The y-axis. Okay. All right. Does anybody remember even and odd functions? Is this an even function or an odd function? Why?
Looks like
That's not why. That's not even.
Oh, even points on the X.
Nope.
Nope, I forgot.
Even functions are symmetrical across the y-axis. Basically, an even function means that the negative value of x and the positive value of x will give you the exact same y value, which means it's symmetrical across the y-axis. So the cosine function is an even function because it's symmetrical. All right, graph 2. Is it a function? Yes. Where is it symmetrical? Yes, this one is symmetrical across the origin. Okay. This one is going to be an odd function, actually. An odd function is symmetrical across the origin. You could also say it's rotated 180 degrees. It basically means that both values change. Negative x and negative y is the same as the x and y. You reverse them. So, okay. Graph number 3. Is it a function? No. Fails the vertical line test. Is it symmetric? Across what? It's across the x, and it's across the y, and I actually also think it's across the origin, if I remember right for this one. We're going to find out in a second because I'm going to put the answer in Alex and see if I'm right. Because that one, if I remember right, that one's the tricky one, that it's actually across all three. Yep.
But if you only chose one.
It would mark it wrong because it says select all symmetries. That's why I wanted to actually check and make sure that was across the origin, because I know for a fact people will get that one wrong. So I wanted to make sure to show you that one. So yeah, basically it's because, again, you can reverse it. So the point over here will match a point over here. So that is symmetrical across the origin as well. It's the diagonal, basically, symmetry. So, okay. All right. How can we tell about an equation? That's not what I wanted to do. Share this one. How can we tell about an equation? Yes. Yes, you could graph it, but you're right. That's not the way that I want you to be able to do this problem. Being able to do it algebraically is also very important. So yes, you could actually just graph this one and see on the graph what it visually it would look like. There are equations, however, when you put them into Desmos and you graph it, visually it'll look one way, but there's things crazy happen, especially around the origin, that can mess you up. So being able to do things algebraically is very helpful. So to do things algebraically for my y-axis or y-axis symmetry, if you remember right back over here, when we're looking at the y-axis, the negative x value and the x value equal the same y value, right? So if it was negative, this is the negative x side. And let's see, that point was 2. On the positive x side, negative 2 and 2 will both give you 0 for the y. Negative 4 and positive 4 both give you negative 3. So the y value stays the same even if the x value switches. Sign. Does that make sense? Okay. So when we're testing for the y-axis, we want to switch the x value and see if it still stays the exact same equation. So in this case, I've got x equals y squared plus 10. If I change this to negative x equals y squared plus 10, does that give me the same answer? No. Because now it's, if I solved it for x, there's my x, I would get negative y squared minus 10. They don't come out to be the exact same value. No, inverse is where I switch the x and the y. So this one, you're just switching the x for the y-axis. You're switching, so x goes to negative x. And then you solve for x again or y, whatever, when it happens, but they should give you the exact same equations. They don't, it's not across the y-axis. That is also known as your even test. Okay, so if you're going to test an equation for even, that's how you would test an equation for even. Okay, so this one is not an even equation. So that's your test for your y-axis. What do you think would be your test for your x-axis? Yeah, I'm going to switch the y's. So the x-axis, I'm changing y to negative y. So I'm going to take the x, leave the x the same, and I change the y. Let's see if it actually finishes writing everything. Good. All right. So what's negative y squared? It's just y squared because the negative times the negative is a positive, right? So this becomes x equals y squared plus 10. Is that the same as what I started with? Yes. So it's symmetric here. All right. That's close enough to symmetric. You get the point. So it's symmetric across the x-axis. Yes.
Wouldn't it be just y?
Yeah. But it's still y squared. So it's still the negative. So it's just like if you had 2y squared, it'd be 4y squared because you're squaring both pieces. All right. How would you check the origin? Huh? No. That won't tell me if it's symmetric. The origin is 0, 0. You're right. But how would I check symmetry across the origin? Yeah. Yeah, you change them both. So we change one for the, we change the x for the y, we change the y for the x. For the origin, you change them both. Goes to, or x goes to negative x, and y goes to negative y. So I have negative x equals negative y squared plus 10. So I have negative x equals y squared plus 10. So x equals negative y squared minus 10. And those are not the same as what originally, so it is not across the origin. So this one is only symmetric across the x-axis. Okay. And for B, you do the exact same thing. I'm not going to do the second one. I can go back here. So this one was symmetrical across the x-axis, which we said. This one actually is symmetrical across all of them. And a lot of times you can tell based on the degrees, because if you look at this one, the x was an odd degree, so the sign's going to change it, right? If you change it to a negative, it's going to stay a negative. If you change it to say a positive. The squares always go back to a positive. When you square a negative, you get a positive. So when you do the fourth of a negative, you get a positive. So it's those evens that are going to allow you to stay that way. So those are the things that to keep in mind when you're trying to check one or the other. The origin is actually your odd. So if it checks across the origin, then it is odd. So that's what we're going to actually do next. No. Oh, I got rid of the even odd because I was going to talk about it there. That's why. All right. All right. Let's talk about mins and maxes. All right. So we have two different types of mins and maxes. One's local and the other one is what? Huh? Global. I haven't heard that one before, but that works. We typically use absolute, but global works. So yeah, it's typically absolute maximum or minimum and local maximum. So, but it's the same concept. It's the biggest one or the lowest one on the entire graph. So let's look at for local maxes and mins on this or first. What are well, they're asking for the minimums, but what are the local minimums on this one? So my local minimums actually is just -2. It just happens to be twice, right? So local minimum values is -2. Where it says L values at which G has a local minimum, that's looking for the X values. So where does that value exist? 0 and 4. So 0 and 4. And just put a comma between them. What's the, well, since we're here, we might as well do them both. What's the maximums? Yes, the local maximums of 3. Do I have an absolute maximum on this problem? Why? Yes, the line keeps going. So this line goes up to infinity, so I do not have an absolute max because the absolute max would be infinity and I don't have to state that. Do I have do I have an absolute minimum on this graph? Now in this one, because the line goes down forever too. So I do not have a absolute max or min on this problem. Okay, I only have local ones. If it was an even function and they both went down, then I would have an absolute max. I wouldn't necessarily have an absolute minimum in that situation. All right. The first graph, A. What's the absolute maximum of this graph? None. And I don't know if you can actually type none. Yes. You actually have to press the button for none. You can't actually type none. What's the local minimum or absolute minimum for this one? -3. Okay. Because even, so this right here is a what? That dashed line. Huh? Yes, it is an asymptote. So that asymptote, but this line keeps going up. It never touches that line, but it keeps going up. So there is no absolute max in this problem. B, what's the absolute maximum for this one? There's values above -2 or +2.
That's none. Because it's not actually on the graph.
Okay, I actually am not sure what they want for this one. I'm going to say 5, and we're going to see if we're right. It shouldn't be none because there actually is values that it does end. We're going to find out.
Does that mean that it doesn't include 5?
It is 2 because 5 isn't included.
Yes, but
Certain.
Yeah, because on the other ones, the hollow circle point was like not equal to.
we're going to find out in a second. I know it can't be 2. It can't be 2 because 3 is above 2 and there's a point that 3 exists.
Where?
3 exists right here. 4 exists right here. 4.999999 exists right there. So it can't be 2. I know that much. If they were at the exact same point, then you're right, a 2 would exist. Or if the point was below that point, the 2 would be the maximum at that point. I'm going to put 5, and we're going to see what it says. They might say it's none. I'm not positive. We're going to test this thing out. What's the minimum? This one's pretty easy. That one's -5. Let's find out. Beauty of doing things live in class and not knowing the answer. Okay, so let's see if it's none. If it's 2, then I'm going to yell at Alex. Nope, it's none.
We're considering that.
I think it's just not shaded.
Maybe.
It's like an arrow.
Well, yeah, that's weird. I don't like that either, actually. I will tell you when you go to calculus, the limit of that's 5. So yeah, I would have claimed it's 5, even though it doesn't technically exist at 5. All the points up to that point would exist. Yeah, it'd been
Or
less than 5. I would never have said none, but at least we know it's now. Now, when you get to this one, you won't screw it up. It's the beauty of live math. All right. This is another one that's kind of a little tricky when it's asking questions, and it's how it's asking questions. So, remember your function notation. Yes.
So on how this would also not include any not being within for a maximum.
Yeah, if there was a point, that wouldn't be a local min or max at that point either. According to that statement there. If it's not an absolute, it can't be a local. All right, remember your function notation. The parenthesis is x. So they're telling you x is -1. So at x is -1, is the answer negative? Yes. If it's giving you the value outside, such as this, it's giving you the y value. So this is saying at y is 0, what is x? So at y is 0. What is x? And that is 1. And now it's saying for which values of x is g of x less than 0? So which values is this function going to be negative? And we need interval notation. So we're going to use, going to be bracket. So it's going to start at -3 and go to 1. Is it including 1? No, because 1 it is exactly 0. So if it was less than or equal to, I would have included the 1. Since it is just less than, I do not include the 1. It's funny. Every time I hit these, I know the answer and I'm saying it's right, but even I am like, is it gonna say that I'm right? Do I get the correct and green light? So yeah, remember the bracket is including, the parenthesis is not. All right, let's do some graphing. That's a 5 and an X.
I think that's an absolute value.
Yes, and there's an absolute value there. So yes, this will end up being a V. All right, so we want to graph this equation here. Whenever you're graphing an equation that is not linear, the goal is always to find the center. Okay? Because if you find the center, then we can just find points on either side of that center. Makes our life a lot easier. Your center is always going to be whatever's making what's inside that parenthesis or absolute value 0. Okay? That will give you an intercept. So in this case, what's going to make this 0 in the middle here? So we take whatever's inside the absolute value. Oh, I'm not on the right screen. It would help if I shared this tab instead. So we take whatever inside the absolute value and set it equal to 0. So in this case, it's just X. So my middle point will be X. Okay? We want that point and 2 points on either side of it. Actually, I think on this one, you probably only need 1. I always typically end up doing 2 just in case, like this one, there's not going to be anything funky happening, but later on things crazily happen. So I would do 2 points on either side. So let me just make a quick little table. So 0 is going to be in the middle. 5 times 0 is 0. And we do -1 and -2 and 1 and 2. Also, when you're doing these, if you have a fraction in the problem, you want to pick numbers that are going to work with that fraction. So if it's a half, pick multiples of 2. So I wouldn't have done -1. I'd have done -2 and -4, or 2 and 4. If it's 3, I'd have done multiples of 3. Okay? Pick numbers that are going to work. So this way you don't have to try to graph hard numbers. All right? So the absolute value of 1 is 1. 1 times 5 is 5. The absolute value of 2 is 2. 2 times 5 is 10. What's the absolute value of -1? 1. So 1 times 5 is 5. Absolute value of -2 is 2. So that is 10. This screen. Now, go back when you're graphing them. I would not use the pencil to pick your points. I would type them in the graph or the point thing. When you're graphing your absolute value function, you are not using the line. You're going to use the ray tool because it's going there and going up. And again, from there and then up. Okay.
Wait, how did you do that?
Use the ray,
Oh, okay.
not the line. Okay, because I want it to stop at that point there. They'll always have a tool like the parabola one typically wants you to pick the vertex and then another point, and then it'll draw the curve for you automatically. The other nice thing about having 2 extra points on either side is it typically is not going to have you choose all 5 points. It's typically going to have you choose one. So you can then test to make sure that you have it right, because it should go through the other point. If it doesn't go through the other point, you know you've done something wrong. So it always helps to check your answers a little bit more when you have that little extra information. All right. Same concept with this. Okay. And this one actually does specifically ask you, if this one says 1 point when x equals 0, they're not always going to be that. 2 negative values and 2 positive points. Okay, so you want 2 on either side of the function. So in this case, we have this. So let's come up with our points for this one. So for this one, you're actually going to do the exact same thing. This one again is x equals 0. We look at the x value right there, and we set that equal to 0. That's going to give me my center, so I know I'm doing the symmetry on both sides correct. So in this case, my center is going to be 0. So 0 is there. I have a fraction in this one. So I am not going to use this -1, -2. I'm going to use -2 and -4 because I want my values to work and give me whole numbers, make my life a little bit easier. You do not have to. You can use the -1, -2 all the time. It'll still work. You'll just have a fractional answer. And I know how much you guys love fractions, so you'll want to do that always. So I don't like fractions, so I'm going to do it this way. All right, so now we plug them in. 0 to the third power is 0. 0 times, that's okay. 0 times -1/2 is 0. 2 to the third power is 8. 8 times -1/2 is -4. And actually, you know what? I don't think it's going to let me do 4. Nope, it is not. All right, what's 4 to the third power? 64 multiplied by -1/2, -32, and it will not let me do that one. It only goes down to -14. So we are going to have to do the 1. So we'll add a 1 down here, and then we will change this to the 1 and 2 because we'll have to do the fractions, which is fine. Sometimes it happens. What's 1 to the third? 1. 1 times -1/2 is -1/2. What's -1 to the third? It's -1. What's -1 times -1/2? +1/2. -2 to the third? -8. -8 times -1/2 is 4. All right, so we've got our 5 points. We can go back and graph those now. The nice thing is when you're doing your points here, you can just do 1/2. It takes it. I messed up. I forgot my negative sign. So notice there's an extra point up here that I don't want. Click the eraser and just click on it. It disappears. And now this one, it has the graph. Just click it. It'll automatically graph it. I think somebody asked me a question the other day. Should you understand what the graphs look like the actual curves? And I said, it's not necessarily important. The only time it's important is when you're checking your work. So because if I screwed up, let me actually undo, I'll show you something. If I left that point there like that, and I hit graph, I'd get graph like that. It will graph it. Okay. Is that a cubic graph? No, because your cubic should go in opposite directions, correct? So I know I made a mistake, so I have to fix it. So I graph that one. And now we have a nice cubic graph. So it does help you check your answers if you have a general idea of what the shape should look like. If you did like the point, say you just clicked, like you were using your pencil and you clicked wrong, it can give you crazy things too. Okay, because it is trying to give you an equation that's going to match the points you gave it. And it has another line over there. So obviously, again, that's not going to be correct. So little things to keep in mind when you're doing your work. You also can just throw it in decimals and see what it looks like too at that point and check to make your answers right. I'm going to do that one's parabola. I want to do complicated parabola. There we go. Let's do this one. It's not at 0. I wanted one that was not at 0. All right. So now this one, y equals x plus 2 squared plus 5. Remember when I was talking about finding your center? We want to find our center point. Okay? Because if we pick 0, 1, 2, or -2, -1, 0, 1, and 2, you're only going to get it on one side of the, in this case, you're only going to get one side of the graph, and you're not going to see that nice curve. So you want the center point. So we're just going to take this piece right here, set it equal to 0. So that means x equals -2. It's always the opposite of whatever is in there. So my center point will be -2. And I do -3, -4. Since there's no fractions, -1 and 0. All right. So now we plugged them in. The nice thing is this should work where that's going to be 0. So it's -2 plus 2 is 0. So 0 squared plus 5 is 5. And that also should make sense because remember, this is basically in vertex form. So it's the opposite of that and that. That's h and k. That's your vertex. -1. -1 plus 2 is 1. 1 squared is 1 plus 5 is 6. If you remember your parabola term, since they found the middle, that one also has to be 6. 0 plus 2 is 2. 2 squared is 4. 4 plus 5 is 9. And that would also have to be 9. If you do the other ones, you can check those out. That'll give you your check to make sure you've done it correctly because they should match up. If they don't, then you've made a mistake somewhere. All right, those are things you can use to check your work. This tab. Same thing on this one. When you hit the graph, you should get your nice little graph. When you're looking at a parabola, remember, that's your vertex form, so we got that there. A is what in this case? 1, and more importantly, it's positive, so the graph should be going up. Okay? So little things to keep in mind when you're looking at your graphs. All right. Square roots, same concept. The only difference in a square root is we don't want to go both sides. Okay, so we're looking for, in this case, the beginning point because the square root cannot be negative. Okay, so when you're looking to graph this, we have the same concept. We're going to set that equal to 0. So in this case, x minus 1 equals 0. So we're going to start off with x equals 1. Since it is a square root, like I said, we do not have to do the other side. We're going to start off at 1. So we do 1, 2, and I think it wants 3 points on this one. 3 and 4. So this is the beginning point and 3 other points. Now, you can do this one of 2 ways. You can do this so that you can just use 1, 2, 3, and 4. You also can do this so you can get actual regular numbers out for your square roots. Okay. So in this case, I did 1, 2, 3, and 4. I will show you both ways to be able to graph this. You can put a square root into the actual plotting tool. It will allow that. So 1 is simple. 1 minus 1 is 0. So that's going to be 0, right? 2 minus 1 is 1. Square root of 1 is 1. 3 minus 1 is 2. So that's going to give me the square root of 2. And 4 minus 1 is 3. So that will give me the square root of 3. The other way that you can do this is we can do this the opposite way. We know this is going to be 1 and 0. I want 1, 2, and 3. So, what's the square root of 3? What's 3 squared? 9. And then you do the opposite. So 9 plus 1 is 10. So that'd be 10. Because 10 minus 1 is 9. Square root of 9 is 3. So basically, you're doing it opposite to get that whole number back there. Square root of 2 is 4. 4 plus 1 is 5. Square root of 1 is 1. 1 plus 1 is 2. And you'll get all whole numbers. Okay, so you can do things backwards as well. Do you have to? No. Yes.
Can you just square the 2 and the 3 and then put that number in? First, take the square root of 2 and 3 in the first one.
Yeah.
Yes.
Yeah. Don't put it in as a decimal. Don't put it in as a decimal, though. That's the one piece you can't do. So when you plot your points, you have the square root button. So what was it? 1, 0, right? Yeah. 1, 0. And then 1, 1. No, not 1, 1. 2, 1. 2, 1. And then it was 3, square root 2. Put the square root symbol. Don't put it as a fraction. Square root 3. Okay. Oh, I didn't change it. Okay. Hit the square root button. So when you type it in, it's 4 square root of 3. Okay. So this way you have it as an actual number. Don't approximate and put a decimal and give it to you wrong. All right. Which also means when you're doing, like if you're doing this on a calculator and you're typing the numbers in, it would give it to you as a decimal automatically. When you're looking at square roots and a lot of those type of things, just do underneath it, because that most likely you can do in your head and just, it's the square root of that and use that information. On the tests and stuff, I would rather it as an exact answer. So I would rather it as a square root of a number instead of it as a decimal, unless it's a application style problem that rounding works. Good question. What makes a cube root different? Okay. What makes it the most different from a square root? Yes. That would be an obvious answer. The more important one, though. Yes, it can be negative. I can do as a cube root of a negative number. What's the cube root of negative 8? Negative 2. So I can take the cube root of a negative number. So unlike a square root where I can't have those negative values, on a cube root you can. So you're going to want to find the middle and then 2 points on either side of those two. So what's going to be the middle point on this one? My middle point is going to be -5 because that's what makes that 0. Okay. So my first point is going to be -5, and then that's going to be 0. That'll be my first point. What's 1 plus 5? 6. So this is going to be the cube root. I got the cube root there. So 3, 6. And then what's 2 plus 5? Oh, sorry. I shouldn't have used 1, actually. Totally messed that one up. It's okay. What point should I have used next? I did -5. What should be the next one? -4 should have been my next one. -4 plus 5 is 1. The cube root of 1 is 1. 1's always the tricky one because it's like, wait, why do I do? Because 1 times 1 times it just keeps giving you 1. And then -3. So it's -3 plus 5.
I think one is one. I think 1 and 0 are like the easiest ones for me.
And they're also the easiest to screw up.
Yeah, I've never once screwed those up before.
That's good. I have. -3 plus 5 is 2. So we omit the 2 there. And now we go the other direction. -6. -6 plus 5 is -1. The cube root of -1 is -1.
Even or odd. Even though positive.
Yes. Evens will make them positive. Odds will stay the same. And then if you do -7, -7 plus 5 is -2. So that's going to be the cube root of -2. And then we graph it, and that's what you get. It looks like a square root in both directions, basically. But again, the key is find the center and go out from there. And even if you go out from there on the square root, what's going to happen is as soon as you plug it in, you're going to realize it doesn't work. So that's the only you just do a piece of extra work that you didn't have to. All right. Now the fun stuff. All right. So a big part of chapter 2 is transformations. Transformations are tricky because it depends on the directions we're going. So the x values is always going to be inside parentheses. Okay, so if the number is inside the parentheses, you're going to move left and right. Okay, because they go with your x value. And it is always opposite of the way that you would think it would go. So this first one is x minus 3. So which direction do you think we should go? Right. You would think, oh, negative, I'm going to go to left. No, you go right. It's opposite of that. Okay. So in this case, I'm going to move this one 3 places to the right. The next one is x squared plus 1. This is not inside the parentheses. It is outside. So it is my y-axis. So I'm going up and down, and it does exactly what you think. So if it's plus 1, I'm going up 1. Okay. So inside parentheses, your x left and right, and you do the opposite of what it says. Outside the parentheses, up and down, and you do exactly what it says. All right, so what about this one? This one's got both, right? So do them one at a time. Inside the parentheses, we're going left 2, and then outside we're going up 3. All right, what about this one? Right one and up two. Now, it doesn't make a difference. These all happen to be parabolas. It doesn't matter if I gave you a square root function, if I gave you a cubic function, if I gave you a natural log function, the rules don't change. If it's inside the parentheses next to the x, it's left and right. If it's outside the parentheses on its own, it's up and down. And it's always the opposite for the x and the same for the y. All you need is 1 point, and then you can drag the graph wherever you want to go. Okay, so that does not change. Covered that one. So, oh, good, they actually are doing it. Here's an absolute value problem. The absolute values are your parentheses. So this first one's inside that, right? So it's a -5, so I'm going to do what? I'm going right 5. This one's outside the parentheses. So I'm just going to go up 1. So it doesn't matter. About this one. Left 4 and up 2. It will sometimes go down. It doesn't always go up.
It's left 3.
Oh, did I go 3? I did go 3.
You almost got yourself.
I was going to say, you didn't want to see me get a red X?
You already have one.
Well, that was only because I skipped the problem, basically.
Yeah. Well, either way, it's better if you don't get another.
Yes. All right. Hold on 1 second. I just want to make sure there's no other graphing ones. Then I'll go do the equation ones. Yeah, let's look at this one. All right, let's look at this one. F of x plus 3. Is it inside the parentheses or outside the parentheses? Outside. So where am I going? I'm going up 3. So I'm taking this point here, and I'm going up 1, 2, 3. I'm not going to y equals 3. I'm moving the graph they gave me up 3. Okay? Big thing. Make sure you don't screw that up. All right, this one.
Right.
I'm going to the right 4. About this one. Square root's just like parentheses. So I'm going left 2 and down 1. Notice, nothing changes. All these topics are basically doing the exact same thing. So don't get stuck up on, oh God, it's a square root. How do I do this? We'll go back to the same rules for translation. And believe it or not, when we move into trigonometry and we're doing transformations with trigonometry, it doesn't change. The rules stay exactly the same. It's funny when Common Core came out, they actually implemented a lot of translations and transformations and stuff in it. And I'm like, this sucks. Why do we have to do this? And then I started looking at the trigonometry and I'm like, wow, this makes things so much easier. So there's a reason for some of this stuff. All right. What about a negative sign outside? Okay. So it's going to change. So if it's outside, what's changing? Your X or your Y? The Y. Okay. So this is changing my Y values. So that means that at -4, instead of my Y being +6, my Y is going to be -6. Actually, I'm going to put a point there. -6. And at +4, instead of Y being 3, Y is going to be -3. Oh, you're right. It is 7. You're right. It's 7. All right. All right. What about this one? This one, the x's are changing, right? So that's x is 0, right? That's literally going to be the same. And then this one, my x goes from 2, -2. And this was 7, goes over to -7. But my y stays the same. So, and again, we're just drawing whatever they have. All right. So what happens if I multiply or divide? Yeah. So remember the whole, if it's always opposite, right? Of addition and subtraction. Same thing with multiplication and division. You do the opposite. So the y value is going to stay the same, but the x value will be cut in half. So, well, 0, 0 works the same. That one's kind of nice. 2. What's 2 divided by 2? 1. What's 4 divided by 2? 2. So that's what happens to it. So I'm going to take whatever my x values are in this case and divide them by 2. The y value still stays the same. So you're still just always doing the opposite for your y values. I mean, for your x values. Okay. So if it's multiplication, so in this case it was 2 times x, I'm dividing my x's by 2. If it was x divided by 2, I'd have multiplied my x's by 2. But if it's on the outside, so in this case, I'm doing it to which letter, x or y? I'm doing it to the y, and I'm doing exactly what it says. So in this case, since it says divide by 2, I'm dividing my y's by 2. So my x stays the same. This was -4. So what's -4 divided by 2? +2. 0 is nice. It always stays the same. -4 divided by 2 is positive or -2. So the y's, you do exactly what it says. Notice I didn't say stretched or shrink because it depends on the way you're looking at it. Depends on how you think if it's shrunk or stretched. This looks stretched. This is stretched on the y-axis, but shrunk on the x-axis. So that's why I don't typically use those terms for it, because it's perspective at that point. All right. If you just stick with, if it's the x, you do the opposite. If it's the y, you do the same. You're gonna get them right 99% of the time. You just screw up. All right. Two steps. So then I think, yeah, actually, oh, that one matters actually. Order of operations do matter in this case. Okay. And again, just like everything else, you do everything backwards inside. So this one's only got a 2x inside, so that works out nice. So the 2x, I'm going to do what to my x's? So I'm dividing my x by 2. So that -2 is going to become a -1, right? So I'm going to put the point there. We're going to erase it in a minute. the 0, and then that 4 becomes a 2. Okay. So that's that one, right? Now, what am I doing to all those points? I'm moving them up by 1. So up by 1, up by 1, up by 1. And then I can erase my original points. So I have 2 transformations I'm doing for this one. The nice thing is this one was on the X, one was on the Y. So it doesn't matter the order you do them in. You could have done either direction. You could have done the +1, the first, and then did divide by 2. It wouldn't have mattered. If they're on the same one, you have to do the order of operations. So in this case, I'm doing the -2 first, and then I'm reversing it. Okay. So this one's going to go down by 2, down by 2, and down by 2. Okay. Hold on. No, I screwed that up. Never mind. I take that back. I did my order of operations wrong. Multiplications first. So we swap them first. It's only 132. Jeez. All right. So I multiplied by negative first, so swapped it, and then I'm moving down. So then I'm moving all the points down by 2. Yeah. Because the X order operations, you literally do them backwards. You do the addition first, then multiplication. Not the button I wanted to hit.
Questions like these, yeah, the first test.
No, because the first test doesn't include the review. Questions like this could show up on the final, but it won't show up on the first test. The first test is just chapter 4. All right. What am I doing for this one? So I'm going to multiply the y by -2. So that means I hate the way this does this one. It's going to reflect over the x-axis, right? So it's going there. And then and I'm multiplying by 2. So -1 becomes -2. Right? And then I'm going to do what? Up 3. Yay. Last one. A couple more I skipped because these were the equation ones. It's not the one I wanted to do. This is the one I wanted to do. All right. Sometimes you're going to get an equation. So all the ones we've done so far for transformations were graphs. Sometimes you get an equation that we want to transform. Same rules apply. So I'll actually do this one and I'll make up another one. All right. So they wanted to go, I think this one was to the left by 7. Oh, it's down by 7. All right, so down. Down by 7. So what does that change? So the f of x is, we're going to subtract 7 from that side, right? We do it on the left side, we have to do it on the right side. So that becomes 5x squared minus 8.
That's a good thing.
Why?
Makes it sound like most like 1%.
Right. But that's actually the exact same situation. Remember where the graph was just below the x-axis? And it had to move up, and it was going up by 3. And I said, don't put it at the 3. Same concept. You're not just replacing what's there, you're adding to its both sides. That's why, if you notice when I did it, which most people will not do, is I did that. I do it to the f of x first, and then it shows you what you have to do to the actual equation. Okay? Makes your life a little bit easier, especially if I wanted to do left by 3. So how does left by 3 manifest itself? It's going to be what? Plus 3, right? And is it inside the parentheses or outside the parentheses? Inside. So this is going to be x plus 3. Which means my x changes. Not my outside. Okay. Remember, that's your function notation. If you change what's inside the parentheses, it changes the x value on the other side. That's why that function notation, when they were going through, was so important that people were like, I'll just gloss over this. So it's always going to be x. It's fine. It's like, no, when you start to get more complicated, those things can change. Okay. And you could combine these two. If I wanted to do both of them, it'd be x plus 3 minus 7. And it'd be the same concept. I'd do 5 x plus 3 squared minus 1 minus 7. And you minus 8. So you can do both of them at that point too. And you could also multiplication or division, multiply x's and everything else by that too. Do the same concept.
So would you give us an equation like that and then say what happened, and then we have to do like, so the graph goes this way, that way, and just write it out in words what happened to the graph?
You could, so yes, I could. I don't think Alex does. But you could have something like that that could show up. They would have to, and that's actually, they would have to tell you the parent function though. So you'd say, if you're starting with the parent function, what is the transformations to get to this? You'd say it went left by 3, down by 8, and stretched by 5, or shrunk by 5, or vertical transformation by 5. So you'd say that stuff in there. But you have to start at that point. You'd either have to be given an equation like this and asked to go to there, or say it's from the parent function would be just x squared. So they have to give you where you're starting from to be able to go there. So, all right. Nice. I think that's it. I think the other two are just directions, which we already talked about. So, yes. All right. And my record.